Well, there it is. We opened the box, and inside we found a rather hefty package of desiccant. We've got a nice fluke8000a multimeter manual, package of fuses, power cord, set of test leads, and then here it is, a brand new, never used, 30-year-old fluke8000a. Not a scratch on it. It's brand new. Nobody's ever touched it. New in the sense that nobody has ever touched it. It came fresh from the factory 30 years ago. It's been in the box ever since. But be that as it may, this was the unit that put Fluke in the eyes of a lot of engineers and users, and made them famous. And we're going to put this thing through its paces. I still have on the faceplate here the protective film. I didn't remove it. So if you're wondering what the strange look is on the face of it, that's what it is. It's a beautiful kind of a blue-green, maybe I don't know, seafoam green or something. Black trim, aluminum accents on the handle. This thing measures AC voltage, AC current, DC voltage, DC current, ohms and the kiloohms and megohm scales. We've got 1, 2, 3, 4, 5 sets of ranges. We have also a 10 amp set of inputs up here for current. And it's a high impact case. Got very high brightness LEDs, easy to see across a room. Not so with an LCD. I kind of prefer the LEDs for my bench myself. I don't have to worry about what angle the lights are or something. Okay, here's something I just realized. I was wondering why these things didn't have serial numbers on them. I couldn't find a serial number on the back sides anywhere, even took a look inside one. But what I do see is that on the box there is a number printed in hand up here, plus there's a number on a label on the side, and I wondered what that meant. And what I see is that on one of the boxes it actually is printed S/N, serial number 3820116 for that one. So the the first meter that I put up for sale is 386, looks like 0096. Yeah. Difficult to peel that down. But 3860096 appears to be the serial number of the first unit. Yes, it is. Alright, so the serial number of this second unit is 3820170. Now how you would get that transferred to the unit, I don't know, I guess you'd make your own label and transfer it there so you'd have a record of it. You know, honestly, it isn't going to help you much as far as the factory goes. There is no warranty or anything on these, long ago expired. But it may be that when you look at any of the documentation would want to refer to a series of serial numbers, so you need to know. Okay, thank you. So let's get going on this thing. We're going to give it a test. I have it right now hooked up to my analogic voltage standard. We're going to dial in some voltages and see what the response is on the meter. It's DC voltage. We're going to start in the 200 millivolt range. We're going to dial in some voltages and observe the reaction. We're on the 200 millivolt scale. So the 0.1 let's try a step here. There's 1, 2, 3, 4, 5, 6, and what this is tenths of a millivolt, so we're working in the hundreds of microvolts. 7, 8, 9, and we go back, we hit 9, so let's go to the next decade. Now we go to the millivolt. 1, 2, 3, 4, 5, 6, 7, 8, 9. Go back. Next decade. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's take her back. We're going to have to go up in range now. Well, let's see. We can hit the 1. So that's 0.1 volt. Alright, let's go ahead and change range. We're now on the 2 volt range. And let's try 0.1, 2 volt range, millivolts. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, the hundredths of a volt. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, the tenth of a volt. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we can go to 1 volt, and that's just, I can go to 1.999, but that would be as high as I can go. We're ready for the next range. Okay. We want to go to the hundredth of a volt here on this range. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. To the tenth of a volt. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're ready for the 1 volt. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, at 9 volts, which I've verified on my reference meter, and as the output chosen from my analogic reference voltage system, at 9 volts I'm reading 8.98. This thing is, the Fluke is, the spec reads 1/10 of 1%. in DC voltage plus a count. 1/10 of 10 volts is 0.01 volt, and 1/10 of 1% would be 0.01 volt. And then your one count added to it would make you be within range of the spec. So we are within accepted specs here, just close. Let's at the 200 scale we're reading 9 even, and on the 2000 or 1200. Okay, we're on the 2 volt scale. Both our reference meter and our fluke. And we're feeding in right at the moment a 1 volt signal, and we're going to load up the fluke here. Right now we see the 1 volt as the half digit overflow, and then we're going to go ahead and add in tenths of a volt. 1, 2, 3, 4, 5, 6, 7, 8, 9. Reference meter is reading 1.9001, and the fluke is reading 1.901, and we're flashing 0 to 01. We're always, the least significant digit can always be off on any meter by 1 digit. That's part of the specification. So let's go ahead and bring in the hundredths. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we bring in the millivolts. 1, 2, 3, 4, 5, 6, 7, 8, 9. Reference meter 1.9991, and the fluke says 1.999 with an over voltage flash. Well, we did dip down once for a second for a moment. 1.999, 1.998, so we're flashing in between 8 and 9 now, and the reference meter is 1.999. So we are good within 1 millivolt or 1 count on the 2 volt range at max scale. Okay, we now have a 100K 1/10 of 1% resistor, very accurate, and we are reading on the 200K scale, we're reading 99.9 with a little flash. 100K at 1/10 of a percent would be off by 0.01. So we're supposed to be within 1 count, and I think 0.5%, if I remember right. 0.2% on the kiloohm scale, 0.5% on the megohm scale, and we're there. Let's take a look at a 1 megohm resistor. Give me a moment. Alright, we have a 1 megohm 1% resistor. 1% should be accurate to within 10,000 ohms, so it would be 101 would be the maximum we'd read. We're reading 1006. So both resistor and ohm meter are reading in the right range, right amount. We're going to do a comparison to our reference meter just to see what it gives us. Alright, our comparison meter is telling us 1.001, 1.003, 4, I'd say 1004. Alright, we have the 4.7 megohm resistor in the Fluke, and we are reading 4.70. We cannot see the last digit, but we are flashing 0 to 1, so there's some activity there, but plus or minus a digit, we're 4.70. That's perfect. Alright, our last resistor to try here is a 10 megohm, 1%. Our reference meter is climbing. We're at 10.025, going up. While that's happening, let's go ahead and 10 million times 1% would be 100,000 ohms. So if we're within 100,000 ohms, which would be 10.1, then we're good. Alright, our reference meter has stopped at roughly 10.075. We could round up and call it 0.078. 10.08, excuse me. Let's go ahead and move the resistor to our Fluke. Alright, our 10 meg resistor is in the Fluke, and the Fluke is stabilizing, and we are at 10.08 right now. Okay, I have the Fluke connected up to a resistance decade, where I can dial in 1% resistors at will up to 999,999. So we're going to try and test a couple of ranges here. We're on the low ohm range right now, and we're gonna bring in there's 1 ohm, 2, 3, 4, 5, 6, 7, 8, 9. Now I'm going to bring in the tens. There's 10, 20, 30, 40, 50, 60, 70, 80, 9. So now we've dialed in 99, and we get the 0.2 for free. Let's go ahead and bring in 100 ohms. And we go overscale, so I have to switch up. Okay. 300, 400, 500, 600, 700, 800, 900. And let's bring in the 1,000 ohms. We're going to have to go up in range. Alright, we're reading 1,000 now. There's another 1,000. 3, 4, 5, 6, 7, 8, 9. Alright, now we're reading 9,999, which would be 10,000 ohms. Give or take a fraction of an ohm, which with the 1% resistors we're working with, we're doing remarkably well. Let's keep going. 10,000 ohms. Let's bring in we're going over, so we have to go up. Here we are at 20, 30, 40, 50, 60, 70, 80, 90, 100,000. Change our range again. 200, 300, 400, 500, 600, 700, 800, 900. There's a megohm. So we just resolved digit by digit every step through our range from the 200 ohm range through the 2000, the 20,000, 200,000, and the 2000 ohm range, 2000 kilo ohm range, up till we read a million. So this thing is reading very well on the resistance ranges, no problem. Okay, let's move on to AC volts. Alright, we are connected up to a generator right now that's feeding in a 60 hertz signal, but we're going to vary the frequency, and we can also change the amplitude. Our Fluke tells us that the AC is coming in at 0.500 volts, and my reference meter is telling me it's 0.500, and then give or take 1 to 3 on the tenth of a mil range. So we have agreement that it's 0.500 volts, and we're reading that AC just fine. Let's go ahead and turn this frequency up. We're going to take it up to 10,000 cycles. Alright. That would be about 10,000 cycles, and the Fluke is telling me it's 0.499, and the reference meter is saying it's 0.4997. So, and then that is good agreement. We're supposed to be within 2 digits, and we certainly are that. So that's at 10,000. Let's go ahead and take ourselves up to 20,000. Okay. Fluke is reading 0.497 or 8. And the reference meter is reading 0.497. This is at 20,000 hertz. We're supposed to be only within 1% here, plus, and then an additional 2 digits. But we've nailed it right on. So let's take a look at the. Well, let's go ahead and take another range, and we'll kick this thing up in value. See what we get. All right. I'm going to turn my amplitude up. Yeah, that's good. All right, we have 10.003 or 4 volts on the reference meter. The Fluke right now is reading 10.07. This is on the 20 volt scale, and again, we're supposed to be within 1% and 2 digits. 1% of 10 volts would be 0.1. That would be 0.1. And we are definitely within that 0.1. And plus we have 2 digits that were allocated, so we are definitely within spec on that. Alright. And that's at 20 kilohertz, by the way. We are at our worst setting. Alright, we have the Fluke connected up to this generator. We're feeding in 10,000 hertz. We're feeding in a voltage of 9.882 across this resistance. 10,000 ohm, 0.1% resistance. And we're getting a reading of 0.999 milliamps. 0.999. So if we are 9.882 volts divided by 10,000 ohms. Alright. Then we should be getting a reading of 9.988, and we're getting 0.999. However, we're supposed to be within 1%. Which puts us at 0.998. And then we're supposed to be within 2 digits. So we are reading 0.999, and within 2 least significant digits, in 1%, we are right in the spec. And that's at 10,000 hertz, which is pretty fast for a voltmeter. And our AC milliamps is 1%. Alright, we've set ourselves up to measure DC milliamps right now. And what I've done is I've got my 0.1% 10K resistor in series with a power supply. I've got a bench power supply over here. I'm right now feeding at about 5 volts. We are referencing our voltage from this reference meter up here, so I see 5.005 or 6. And I've done a calculation ahead of time, and we're going to change it now because I see my voltage has drifted a bit. We're at 5.006 divided by 10,000. So how do I get this without seeing glare? Okay, I think we got it. We want to see 0.5006, so 0.500 will be what I'd expect to see, and I am seeing 0.500. Perfect. All right, let's turn our voltage up to 10 volts. All right. Looks like we're going to stabilize at 10.005, 6, 5, 6. We're going to take 5. 10.005 divided by 10,000. And I come up with 0.001000. So 1 milliamp. And I am getting 1 milliamp. So again, we're perfect, dead nuts. It's supposed to be within, well, DC milliamps, 0.3% plus a digit. So, but we are right there. So there's 2 readings we did. The 2 volt range on the, 2 milliamp range. We could go to the 20. Our reference voltage is settling in at 19.92. So 19.92. Let's try that again. Divided by 10,000. I want to see 1.99. 1.99. We're right on. So there's another scale and a different voltage range, and yet we are hitting it perfectly. So let's give an applause to the Fluke. I think it's passed the DC milliamps just fine. So we've tested AC voltage, AC milliamps, DC voltage, DC milliamps, resistance in the kilo ohm and megohm range. This meter is working wonderfully. The only thing I haven't checked out is the 10 amp input, and frankly I don't have anything that would be capable of providing that kind of amperage. I'm going to believe that it would be just as accurate. I have every reason to believe it would be. And normally you're not splitting hairs anyway when you're working at that amperage. You're trying to get something grossly close. So I don't think we're going to have a problem. Again, this meter is brand new, never had an owner, not a scratch on it. It would make an absolutely beautiful addition to anybody's workbench. Anyone who wanted an accurate reference source for voltage and current, both AC and DC, this would be it. So happy bidding. You know, let's take a moment and take a look at this manual. This manual, it gets into the theory. Theory of operation, simplified block diagrams, circuit description, maintenance, calibration, replaceable items, schematic diagrams. This thing is, it's got it all. There's some schematics right there. So you will not be left in the wilderness with this unit. You've got everything you need, actually far more than you'd normally get. Extra set of fuses, nice set of test leads, your cord, the meter. Good luck, guys. Bye.